Hi, this is George Mott with Enterprise DNA, and in this tutorial, you will learn how to execute and interpret the paired samples t-test using Excel. Okay, so the paired sample t-test is going to check for a difference in the means of observations. So we're dealing with quantitative data here between one time period and another. So we're also dealing with time series data here. So this is going to be a hypothesis test with all of the fittings that go along with that. If you want to learn a little more about how to do hypothesis tests, especially in Excel, you can check out my book, Advancing in Analytics. We won't go too much into the theory here. Suffice it to say, we will be using the analysis tool pack in Excel, which is something you can learn more about in the book. We will be testing at the 95% significance level, and we will be using a peer-reviewed data set from PLOS ONE. Basically, what we want to find is whether there's a difference in the means for group 1 between time 1 and time 2. So we're basically going to try to reproduce a research study. So this data will be available to you. We're going to dive into Excel and run this paired sample t-test, and then we'll kind of regroup and go from there. Okay, so here's my data, and again, we'll make this available to you. Now, these are individual patients. So basically what happened is they were measured at period, or it's called here volume 1, and then given another measurement in volume 2. So we need to know the measurements at both time periods. Otherwise, we can't use these patients, these observations. So that's one thing to know about the paired samples t-test. We'll regroup on that later. But let me take the average, not the mean. The Excel function is average. And let's compare. So we've got about 45.26 versus 45.39. So it looks like volume 2 is a little bit higher. So you may think that, okay, so there is a difference, right? But the nice thing about using hypothesis testing is we want to really dig into this and decide kind of probabilistically whether what we're seeing here is just a fluke or not, right? Okay, so let's get rid of this data. I'm going to go to my analysis tool pack. That's going to be in the data section here. Now, if you're not familiar with the tool pack, you can check out the book on how to install it or do a web search. And we're going to go to paired sample t-test here. So there are a lot of options. We're going to use this one. And it's going to ask us for 2 ranges. So that's easily done here. Control-Shift down. I'll select that entire range. Variable 2, that's going to be column C. So we've got the same number of observations in each group, which makes sense because we need those observations for each patient. We do have labels in the first row, so I want to set that on. Hypothesized mean difference, we're going to leave this blank. That's going to assume, hey, is this mean difference significantly different than 0, right? We could check, is it different than 5 or minus 10 or whatever, but 0 is the most common. And let's go ahead and just put this in the same worksheet here. E1 is fine. I'm going to click OK. So this is a very menu-driven approach, right, to find the difference, run this test. So we see the same numbers that we did here. We're saying the hypothesized mean difference is 0. And we're going to look for the two-tail p-value, okay? So if you want to learn more about one-tail and two-tail, etc., you can check out the book. But we see a p-value of 0.75. So this is telling us that it's probably not a significant difference. So even though this number is a little bit higher, statistically speaking, we're not able to say that it's likely really different than 0. So again, just kind of taking your analysis to the next level by applying hypothesis testing to it. Okay, so let's recap here. Before we do that, just try to keep this number memorized. So we have 0.751. Okay, and let's go back to the slide and check this out. So this is the data for group 1. We can see here from the PLOS ONE journal 0.751. So we were able to reproduce the research results of this report, which is pretty cool for us, but it's also cool for the researchers because by having published their data and given anybody access to it, anybody's able to really make sure that they did this right, and it just makes everything a little more confidence inducing when that data set is available to the public. Okay, so to recap here, again, often the pair sample t-test is used when there's some kind of intervention, whether that's in medicine or marketing or education, right? So this is often a social science kind of test to use and know whether there's been some change given an intervention. The downside here, not really a downside, but just a difficult side of it, is that we do need to have the observations for both time 1 and time 2. Generally, it's going to be pre and post intervention, right? So that's hard to do often in business settings, right? To get one set of measurements, let alone 2. And then again, like I said, you can check for differences other than 0, but it's most common to check for a difference of 0. Okay, so that's everything for the paired sample t-test. Hope you learned something. We used the tool pack again. Check out Advancing into Analytics. We at Enterprise DNA also have other material on Excel, analytics, modeling, etc. So I'm George Mott with Enterprise DNA. Thanks for tuning in.
Hey everyone, thanks for tuning in to Enterprise DNA TV. If you enjoyed the content covered in this particular tutorial, please throw the video a like. It really helps us and we really appreciate it. Also, don't forget to subscribe to the Enterprise DNA TV channel. We have a huge amount of content coming out all the time from myself and a range of content creators, all dedicated to improving the way that you use Power BI and the Power Platform. Lastly, check out Enterprise DNA's website. Plenty of resources and further learning that you can access very easily. All the best. Take care.